Okay. Right, properties of logarithms. Let me start twice. Okay, so it says expand each logarithm. Log 2 minus log 3. Log 3 plus log 11. This one. Log 6 plus log 7. Log 5 plus log 11. Log 7 plus log 8. Log 12, take log 11. The power comes down to the front, so it's a third of log x, or log x over 3 if you like. This one's a half of log x. Half of log of x. Log of a plus log of b. 5 log x. That 6 applies to u times v. So in other words, it's the logarithm of u to the 6 times v to the 6. So the 6 comes down to the front. And it's 6 log u plus 6 log v when expanded. This one, the index of 5 right there, only applies to what's immediately to the left. So it's log of a plus 5 log of b. Now condense each expression to a single logarithm. All right, this is the log of 6 over 5. This is the log of 12 over 5. Wrong. It's the log of 12 times 5, which is the log of 60. This is the, well, I guess if they want to, okay, the log of 6 times 7. Whoops, that looks like point, which is log 42. Log of 12 over 11. And I'm just going to evaluate that just for fun. So that would be 1.09, and then that bit's repeating. 3 log of x is log of x cubed, although you may see it like that. Likewise, this one, log of a over b, log of the root of x hold on, log of x times y to the 5, beg your pardon, log of u to the 6 over v to the 6, which is sometimes written like that. This one of x times y to the 4 is sometimes written like that, or it could be equivalently written like this. That's all the same. And this one is u times v times w. And for this one, okay, so first combine the logarithms like that. What's that? 5 squared, and then add, and then, all right, so log of 75. Okay, so then this becomes log of 4x squared over y squared. And then all of that is divided by 75, which will be log of 4x squared over 75y squared. Fine. This one here, well, you can't condense by usual rules. Could be this, however. Like that, and now we'll check. Okay, that's correct. Seven at 8. Yep. Yep. All good. Okay. Four x to the 4 WVU. 4x squared over 75y squared. Indeed, it can't be simplified, but you could technically render it like that. All right, that's done. Next up. Writing logs in terms of others. Use the properties of logarithms and the values below to find the logarithm indicator. Do not use a calculator to evaluate the logs. Okay, so we have to find log of 1 over 49 using the properties of logs. Why is this not coming to me? Well, 1 over 49 is 7 to the minus 2, is it not? And therefore, it'll be minus 2 times log of 7, which is negative 1.6. A seventh is 7 to the minus 1. So this will be the negative of log 7, which is, I don't like it when I have exact equal signs when they're not true. So approximately. And here we go. This is approximately negative 0.8. 1/12. So this will be approximately negative 1.1. 3 over 2. So that's log of 12 over 8. Which is the log of 12 take log of 8, so 1.1 take 0.9, so about 0.2. 2 over 3 will be the log of 8 over 12, which is 0.9 take 1.1, which is approximately negative 0.2 in this case. So log of 64, well, that's double the log of 8, which is about 1.8 in this case. 7 over 12, log of 7 take log of 12, which is about negative 0.3. 144, that's the square of 12. So it's about 2.2 in this case. Log base 7 of 24 is 24 over 11. Okay, that's log base 7 of 6 plus log base 7 of 4 take log base 7 of 11. That's 1.6, that's 1.2. The approximate difference then is 0.4. Okay, this one here, not so clear. Okay, so how about this? Wait. Just a sec. Okay, 9 times 6 is 54. No, it doesn't work. Doesn't work. So we've got 7, 2 times 7 on the top, and 3 on the bottom. So how on earth does that work? Where does the 7 come from? Oh, goodness me. There's a 7 right there. Okay. I don't know why. That's obviously 1. Okay, that's log base 7 of 56 over oh goodness me. Why am I stuck? Uh-oh. Wait, let me think. Okay, I've got it. Two over 3 plus right? Because then you end up multiplying them together to get that. Okay. And that there is 6 over 9. That there is a third of... Is it? I'm probably going about this in a really, really roundabout way. Goodness me. Sometimes you meet these ones. Okay, so it's log base 7 of 14. Take away log base 7 of 3. Agreed. If we know log base 7 of 9, okay, and log base 7 of 14 is log base 7 of 14. No. Okay. I was doing better before when I had it all multiplied by 3. That is 7 times 2 over 3. Not sure why I'm not getting that. And because that is 7 multiplied by 2 over 3, you can now separate it into smaller bits like that. And you recognize that 2 over 3 is the same as 6 over 9. Okay, so that there is 1. That there will be 0.9, take 1.1, and we'll end up with the approximate answer of 0.8. Okay, 700 now. Okay, that's log base 3 of 7 times 10 times 10 times 10, which is approximately 1.8 plus 2.1 times 3. So 6.3 plus 1.8 is 8.1 roughly. 324, that's the square of 18. $48, and then times that by 5, that's 240. No, so that's not going to do. Square of 18, which is built out of 2, 3, and 3. Okay, you end up with that 2704, and that's and 6 over 8 is the same as 3 over 4. And so it'd be 9 of them. Oh, right, okay, so I get it. Okay. Okay, so I can work out log base 9 of 48. I know what that is. That's just 1.7. And then yeah, look, 324 is 2 squared times 3 to the 4, is it not? Okay, that's built out of 2 and 3. I get it. No need for all that. Okay, so what it is it's log base 9 of 6 twice. So in other words, this much better. All right. log base 4 of 7 over 16. That's 4, okay, log base 4 of 7 minus log base 4 of 16. Okay, that's 1.4 on the left. And that right there is going to be 2. So it's approximately negative 0.6. Log base 5 of 150 2 times 3 times 5 squared. Like that. That's fine. That's 6. There. Log base 3 of 11 over 30. Mm-hmm. It's 3.1, and 2.2 minus 3.1 is that. Log base 6 of 9 minus log base 6 of 4 plus log base 6 of 10. So 1.2 minus 0.8 plus 1.3. And that there is 2.1, and 1.2 minus 2.1 is negative 0.9. Use properties of logarithms and the logarithms provided to rewrite each logarithm in terms of the variables given. So okay, so 5 squared, you can express that as, log base 6 of 5 squared, you can get that from doing 2t and taking away an r. Like that. That's the third power of 8. So it would be 3 minus y. Mm-hmm. Like that. Four, 3, 2, which is 2, 1, 6. Oh, of course. Yeah, that's silly. Okay, so that's it, I think. Okay, should check. Okay, that one needs checking. That's fine. Okay. Log base 3 is 700. Okay, I don't get how that's not. I'm sorry, but I think that has to be mistaken. That absolutely has to be mistaken because log base 3 of 729, that's what gives you 6, and this is clearly asking for 700. So it's a mistake. It has to be. It absolutely has to be. There's just no way that that's possible. And my reasoning is sound. Okay, exponential equations with logarithms now. Right, so what is this? calculator permitted or not? If it is, then all right. Okay, because there's no custom logarithm button on here, I'll have to do the change of base formula. So it's to what power do I have to raise 17 in order to get 62? And for that, I've got to do log 62 divided by log 17. So about 1 to the nearest 10,000th, that's 4 decimal places. So 1.4567. We'll check. Okay, that's valid. All right. Log base 9 of 39. So I write log 39 divided by log 9 to get 1.6674. I'm saying it like a New Yorker. 4. Okay. Log base 9 of 29. That. How long does it go on like this for? It's getting pretty tedious. Just a few. Okay, log base 13 of 15. Is about 1.0558. Oh, that's just common logarithm. 1.8692. Log base 20. 58. .3554. Come on. Log base 47 of log divided by log like that. 1.4217. And finally, log 13. 1.7035. Okay, now what to do? Divide both sides by 8. Log base 13 on both sides. And then divide that result by 7. So log base 13 of 73 over 8 all over 7. Wait, it says solve. Right, okay, fine. So it would not be okay to leave it in that format. All right. I cannot believe that a calculator this bossed out doesn't have a custom logarithm button. And my other calculator is broken. So Wolfram Alpha, here we come. Okay, how do logarithms work on here? So I'll just type in log 10, comma 1000, and I get 3. So that's how they work on here. So log, open brackets, 13, comma 73 / 8. And then all of that has to be, so that, which is 0.1231. Here, log base 9 of 49 over 8 divided by -5, and that will give you x, which is approximately what? Negative 0.164, negative 0.1650. There. Okay. Gather the powers. Log base 9 of both sides, and then take 3. Negative 1.1442. Here, take 4, so 62. Log base 17, add 10. Whoops. Whoops indeed. Plus 10, like that. Can't believe I'm losing daylight to this. 11.4567. Come on. 86. All of that divided by 4. .6919. Take 8, 26. Common log of 26 divided by negative 9. That this thing can do without friction. There. Natural logs are going to be involved now. So 23, learn 23, take 4. Okay, so it looks like this is garbage. And you have to close that off with brackets. Well, apparently not. Apparently, I don't know my E power table. Negative 0.8645 is fine. Both sides over negative 10 to get 8.1 on the right, log base 10, log base 8 of that, and divide that by negative 5. Result. Why does Wolfram Alpha take centuries just to do the most? It's unbelievable. I thought we were living in the future, right? Here we go. Negative 0.2012. There. How many more actually are there? Just 24. Just 24. Not so bad. Okay. 42.3. Ln 42.3 over 5.9. Then add 8 to that, and divide all of that by 10. You know what? All right. Add 7 to both sides, so negative 84, divide that by negative 3 to get 28, and then learn 28. Take 1 over 5, good enough. Take 2.9 from both sides, so negative 29.9, divide that by 5.3. Learn, take 5, and divide all that by 8. Take 1, so negative 60, divide that by negative 4 to get 15. Learn of 15 plus 7, all of that over 2.2. 89 over 7. Minus 2, and divide all that by negative 3. Add 6, so negative 31, divide that by 5, so 31 over 5. Add 8, and divide all that by negative 6. Take 6, so 88, divide that by 5. Ln of 88 divided by 5. Add 2, and divide by 2.9. Add 2, so negative 96, divide that by negative 3, which is 32. And then ln 32, take 1 all over 4. And these I'll check later. Right, I have to check the ones that I've done though. Good, 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 good. Good, 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 good. That's fine. That's fine. And these have not been done or calculated fully yet. That's fine. Finish that now. Okay, be well, be well.